Good morning, everyone. I'm Jeremy Stevens, and I'm your panelist for our discussion on semantics and analytics of healthcare data. In the next hour, we're going to hear from our four esteemed panelists discussing semantics. And I want to kind of break this up into really two sessions. We're going to give each of them a brief introduction to their role and their company's focus. And then we're going to make it a little more interactive. So there'll be some homework for you guys to ask one or two questions. And during that, we'll share the conversation going forward with some discussions that we prepared as well. Just to kick things off, I need everyone to put their hand up in one of three capacities. So you've got to put your hand up because I'm going to count. And so there's got to be a full number of hands going up. We're interested in figuring out if you're in healthcare business, healthcare IT role, or other IT role. You're going to quickly decide that. Let's get the vote going. Show of hands for who's in healthcare IT. Good to know. And now healthcare business role. Good stuff. And then other IT. All right, that will help frame our discussion a little bit. That's sort of the mix we were expecting, and thanks for that. So I'm going to start in 2005. We'll start with just a quick idea, and then we're going to hand it over to the panelists. Terry Gross was interviewing Tracy Morrow, otherwise known as Ice-T. At the time, there were a lot of new hip-hop artists coming in, kind of blurring the world a bit. They were rhyming, but they weren't really true hip-hop. So Terry asked Tracy, how do you identify legitimate hip-hop artists? He responded, game knows game, baby. You may be wondering, what does this have to do with healthcare analytics? I think what he really meant was, you have to have expert knowledge. Then you're capable of answering complex questions by interpreting domain-specific information. But maybe more to the point, that was in 2005. We've moved forward from there, and our panelists are going to talk about innovations in analytics specific to the healthcare challenge so that you don't necessarily need to have Ice-T's implicit expert knowledge to determine semantics. Technology has moved forward, and we're going to have that discussion today, looking at technical approaches to richness of analytics from a healthcare lens. And without further ado, let's get started. Our first panelist, Sean Dasmachi, brings to Apixio 19 years of combined academic and commercial experience in several industries, including life sciences, medical devices, healthcare IT, and the internet. He is currently CEO and board member of Apixio, the leading big data solution provider in healthcare, which he helped co-found. Sean received his undergraduate degree in genetics from UC Davis and his PhD in the multidisciplinary field of vision science from UC Berkeley.
Thank you. Well, thank you for being here, and thank you for having us on the panel. Give you a little bit of a background to Apixio. Apixio is a small, fast-growing company in San Mateo. We're focused primarily on taking new technologies such as Hadoop, Cassandra, machine learning, and semantic analysis to help data mine both unstructured and structured data in healthcare and try to make sense out of the data for the purpose of certainly cost, quality, and revenue. The use case that we're most focused on today at Apixio is to help our customers who are insurance companies and fully delegated provider organizations, risk-bearing provider organizations. Help them take their clinical narrative, whether it's unstructured text data or whether it's scan data, and help translate that into risk scores that could be used in risk-adjusted payment. Now, for those of you who are not necessarily familiar with risk-adjusted payment, risk-adjusted payment is used for an HMO-style plan by Medicare, which is called Advantage, and also under Affordable Care Act, or the Obamacare. It's also used for risk pooling and balancing between different regional plans for their small group and individual members. So at the end, what we're focused on and what we'd like to do in the short term is to help our customers become more sustainable, and in the long run, we certainly would like to bend the cost curve and improve quality of care.
Thanks. Next up, we have Chris Tackerbury, Clinic and co-founder and Chief Executive Officer. Chris Tackerbury is a former physician with 9 years of anesthesiology and intensive care experience in the UK. Chris left clinical practice in 2000 and combined the benefits of his medical expertise and degrees in computer science when he joined ISOP, a UK-based healthcare company operating in more than 35 countries. During his time at ISOP, Chris oversaw a portfolio of more than 30 products, driving approximately $320 million in total revenue.
Thank you very much, Jeremy. And that description of me is why I like to describe myself as a recovering EMR vendor. So I run Clinic. We do two things, quite simply. We take free text and turn it into meaning and structure by converting it initially to Snowmid CT. And we provide query tools to enable the abstraction and aggregation of that initial output. And our typical partner is another vendor of either analytics or computer-assisted coding or EMR solutions. Can you hear me okay? Okay. So we don't drive a use case for our partners. We let our partners do that for themselves. And if I summarize across the range of partnerships that we have, we've got some customers and partners here in the Bay Area. It's about finding needles in haystacks. So there are groups of patients who have significant value to an organization, either because of the risk they constitute and the healthcare spend we're going to drive, or because they're potential candidates for clinical trials. A whole range of reasons why people are looking for small groups of patients defined by rich clinical criteria. And you can't find those patients if you don't interrogate unstructured data. People we work with have found that up to 85% of the information they need to do their job, to do their work, to deliver value, is in unstructured free text as opposed to structured data. And we get out of bed every day trying to improve our technology to gather as much meaning out of that free text as possible to support analytics applications.
Thank you. Dr. Sia Zadeh is an adjunct professor in the Agino School of Business at the Golden Gate University. Dr. Zadeh has more than 25 years of experience in a variety of IT organizations, developing business strategies and product specifications for the use and application of IT to many industries, particularly healthcare organizations. Sia Zadeh earned a doctor's degree from Columbia University in New York.
Thank you. And as was introduced, my primary affiliation in this event is to Golden Gate University, Agino School of Business, where I teach. As part of the graduate program, we have a Master of Information Technology with focus on, and sometimes subdisciplinary practice on healthcare technology information management. In addition to that role that I have at Golden Gate University, I'm also involved with a technology company called Sandbox Solutions, where I am the regional vice president. And Sandbox Solutions, similar to what you heard, is a software solution and service provider that collects, aggregates clinical and claims data into a data warehousing capability and analytics to bring value at the clinical decision level to the end users, whether it would be providers or whether it would be ACOs, critical care organizations, for the purpose of risk layer stratification, quality measures, and identification of gap in care. And as part of that experience that I've had in industry, in the role of IT, that's going to carry over in a graduate program that a Golden Gate University offers. A lot of students these days are facing with the challenges that information technology has, particularly for the healthcare, where the complexity of data, and as you heard from some of my colleagues, and we're going to get into it in terms of unstructured data, structured data, the complexity of the business processes, and the type of variety of not only organization in terms of establishing a very, solid data governance and compliance is basically, it's a very interesting topic, and bringing years of experience both from industry and academic for this graduate program.
Murray Brozinski is Chief Strategy Officer and Head of Business and Corporate Development at Healthline. He has guided the company's strategic direction and partnerships since inception. Murray has 20 years of experience founding, operating, and advising high technology firms. He is founder and principal of Cambrian Technologies, a business development firm that helps innovative technology companies develop strategic partnerships and bring their technologies to market. Prior to Cambrian, Murray was president of NetCentives, a leader in digital loyalty programs.
Thank you. So I was at a big data conference recently, and I wish I said this, but it was a professor at Duke who said, big data is like, have any of you guys heard this? Big data is like teenage sex. Nobody knows how to do it, but everybody else says they're doing it, so they say they're doing it too. And I think it's true. I think in healthcare right now, we're moving into the phase of analytics. We've digitized data, we started to share data through HIEs, and now we're starting sort of the age of analytics, but all the analytics, as you've heard up here, are really operating on a small subset of the data available. So Healthline has spent the last decade building what we call a semantic taxonomy. It's like an allusion to Hitchhiker's Guide to the Galaxy. It's like the Babelfish. The whole idea is we take data, whether it be structured or unstructured, from disparate systems and pull it together in a way that makes it accessible for various applications. So we don't develop the applications, but some of the applications that we're enabling richer data sets for are things we'll talk about up here, like population health management and building predictive modeling, clinical decision support, and then search and discovery. We had 125 people located in San Francisco and New York. We developed this platform and we started out in the direct-to-consumer market. So we actually have a media business that's a place for consumers to go get health information, make health decisions. Very, very engaging experience using this platform, using data to provide very personalized experience. And then we've taken that platform and now moved into the provider market. So we work with provider, mostly big at-risk organizations that are trying to bend the cost curve and affect outcomes. We work with large payers, and we also work with HIT and health service companies that service those segments.
Thanks, guys. So, I know you're working on your homework, you're thinking of a couple questions. I'm not going to start right away with questions. We'll make me be the guinea pig for that, and then we'll go back to your homework. But all of you guys have talked about this sense of timing that we're sort of at the moment of analytics here. I'm curious, as we think about disparate sources of data coming into a healthcare organization, all of the customers here today have challenges normalizing this across an analytics framework. So maybe I'll start with Chris, but really this is for all the panelists. Can you give me a sense of some of the best ways to normalize the input streams across these divergent data sets so that you can have a run at a faster return to insight?
Sure, thanks Jeremy. I think the answer to that question depends. It depends on what business purpose is driving the aggregation and the analysis. A lot of our partners have been quite successful with ICD-9 as a normalizing taxonomy. Obviously, Murray's talked about a proprietary taxonomy that's been developed empirically, which clearly has value, otherwise he wouldn't be doing it. So I think you have to decide what problem you're solving and then decide how you're going to normalize your data. I clearly think we set our kind of flag out for SNOMED CT. That's for two reasons. Number one, it's free in all the markets we trade in. and it's had about 600 man-years worth of clinical authoring efforts go into it, which is unlikely to be repeated privately. And so we see that as a rich resource. It's very granular. There's around 1.8 million possible expressions that you can describe in SNOMED CT, and it's very strong in areas where ICD-9 and 10 are weak around symptoms and symptomatology. And that kind of thing is really important as we're moving to value-based care. So if I'm going to pay my provider as a payer based on how well a particular strata of patients are feeling, as opposed to how many chargeable treatment items I carried out, then that kind of more granular clinical information is really important. That's well described in narrative and it's well modeled in SNOMED. It's not perfect. However, we found that a lot of our partners need something simpler, much simpler than that. And so we can provide some abstractions that are much higher level. But I think the normalization's got to be rich, but the choice is determined by the use case.
Murray, you want to go?
Yeah, sure. I'll just build on what Chris said. I mean, I think there's really, at the high level, there's two ways. You can mandate a standard, so you can do HL7 for a language. It's not going to happen. It's just too complicated, too difficult to do. So I think where Chris is going, you have to pick some terminology to normalize against. And ours, as Chris pointed out, is proprietary, but we actually have incorporated all of the available terminology. So we have SNOMED, we have ICD-9 and 10, we've got LOINC, we've got CPT for procedures, we've got a whole host of available control terminologies, and then we've built extensions around that. So we've got a lot of experience, different use cases with consumers, with providers, and so understanding what language they're using. So when you think about the free text, all of those terminologies are great, but they're controlled vocabularies, and free text is uncontrolled. And so we have a lot of experience now in how people are characterizing certain things, whether they be specialists or patients, millions and millions of free text documents that we've gone through. So that's all built into the taxonomy. So the approach then is we basically do an auto mapping, and anything that's a direct hit into our taxonomy, we know is going to be accurate. Anything that's off even by a little bit, then we do a manual look at it, we do some QA, we feedback, and that's how we build the taxonomy. So it's laborious, but we've been doing this for, of course, 10 years, so now it's a very, very rich kind of babblefish that I described before. And normalization is critical. I mean, you can't do any analysis and expect it to work, especially in healthcare, unless you're confident that you've got a clean data set.
Great.
So at Apixia, we're very focused on a very specific use case, and that's being risk adjustment scores. And for that purpose, we have developed also a very rich taxonomy or knowledge graph that we use. And this knowledge graph is actually very extensive. It's over 4 million terms in it. And it's really consists of both combining various specific ontologies that exist in medicine, but also borrowing a lot of the common expressions that are used in the clinic and with patients as well. And the other part of the focus is how do we take such a large taxonomy or knowledge graph and put it to use at very high scale? Because our customers demand processing at very, very high scale. We get terabytes of data in for any one processing that we're doing for a customer, for any one of the data analytics sweeps that we do. And this data pours in at very high throughput, and we have to be able to handle that scale. So the way we handle that, be more specific or maybe more technology-oriented folks, is to take data that's coming in and first normalize against syntax. Once it's in a structure that we get access at very high scale, and we store everything in Cassandra where we could access it at very high scale, then we take the data and we further enrich it by creating these event streams that have very specific properties as it relates to the patient, the time of the care being rendered, and all the other related information to that using our taxonomy. And that we store back into our high-scale non-relational data store. And then we can make very high scale and speedy, complex inferences from that data. And of course, again, the area where we're focused is risk adjustment scores, which is to take hierarchical condition coding and translate that into specific, scores that we give back to our customers.
Okay, great. Did you want to comment on that one, or do you want to go next?
I'm just going to add what my colleagues have said, that one of the key issues that I generally run into when I talk to executives of the healthcare organization, and I'd like to hear from some of the folks who raise their hands, the folks who are in the business leadership role, is access to correct and appropriate data to make intelligent business decisions. So one of the key issues that was addressed here, that is in healthcare, you have a volume, variety, and velocity of the data that comes from all over at many levels. And as HIBS has defined, your challenges are at the interoperability level, at the 3 levels. You have a foundational level of interoperability, which is being addressed mostly through some of the health information exchanges or regional exchanges. You have the structural side. But to be able to do gap analysis for healthcare, to do risk stratification, and to get value out of it. How do you get value out of all these different types of data set, the unstructured, structured data? How do you manage the semantic interoperability, which is really the last frontier on technology, still seems to be elusive in many organizations, despite significant investments they've done in EHR, EMR over the past several years. And they say, well, I have the data, but my version of Epic in this instance doesn't talk to my other version of Epic in the other instance. Or I have affiliated physicians who are using a different EMR, EHR. So we are inundated with these challenges to collect the data, map them into something that's useful in a type of standards and emergence, such as the continuity of care records, the continuity of care documents, CCR, CCDs, and bring them as least disruptive and not intrusive at the point of care. And these are some of the semantic interoperability challenges that organizations are facing. Hopefully we're talking a little bit more about it.
So let's stay on that business idea, the sort of richness of value in data for a sec. If data mining is useful for semantic analysis, how should customers think about quantifying it? I mean, is there an idea that data can be measured in dollars and cents? Is there a goal value for data in healthcare, or what is the break-even point for running the mining operation? How can customers build that kind of framework?
Back at it first before I pass it on to you.
I'd be happy to. Thank you. Well, go ahead, please.
I mean, it's going to vary from organization to organization. I think one thing was said in the previous panel, and I'm sure most of you have experienced that. You need to have a well-defined business strategy and objectives of either IT or your data, what you want to do with it. As a executive of an organization, let's say if you are in an accountable care organization and you are tasked with finding a population health management strategy, that will drive your data mining. You have to identify the disparate sources of data, collection of them, aggregation of them, mapping them, combining variety of data to do that. So that's going to be the business side. Your business imperatives should define and drive. In addition to it, this is an industry that's highly regulated, so your business imperatives and your compliance are generally should be. When I teach health information technology, I always tell people that health IT is a nexus of business imperatives, compliance, and IT advancement. But IT never should drive. Your business strategy compliance should really drive the value you're going to get out of all your IT investment resources.
Yeah, I 100% agree with Sia. At Apixio, we pick risk adjustment because it has such a specific value to it. CMS has put a very specific value. For example, a nugget of gold, if you will, or a piece of information as it relates to, let's say, diabetes with various types of complications is worth to the health plan or the delegated provider organization as much as $2,000 to $4,000. COPD is worth, $4,000. So these specific pieces of information, of course, it has to meet the requirements put forth by CMS, which are not just simply finding a piece of information, it has other requirements that has to be met. But once you find it, it has a very specific value. In fact, we know our ROI to our customers down to fractions. We know exactly, what the return on investment is for them. And I think that's very helpful for a company that's young like us, that's trying to get a foothold in the marketplace, for us to have a very clear ROI that we present to our clients.
I was going to just add to that. So in Chris's case, it's a very, very specific use case. But I think of data as a dependent variable. I don't think of it as a currency at all. So data is useless unless it's actionable. And then depending on what you do with it, what's the value of that outcome? And so, for example, 5% of patients account 50% of the costs in the U.S. healthcare system. In Medicaid, it's 1% account for 25% of the costs. So very high utilization. So if you can get data and then do a much more granular job of stratification, for example, and go after a certain population, you can describe it, and you can, then you can start to do predictive analytics and go after them earlier and intervene. You can save enormous costs. And I know we're talking very conceptually here, but just to give you an example, I was literally reading a study in the American Heart Journal recently where they looked at what were the causes of readmission for congestive heart failure patients. And they looked at medical and socio-environmental, which brings up a lot of the unstructured. So it's not just about can you find clinical information, it's can you find information that's going to help us make better decisions. And so they looked at it, and it turned out that readmissions weren't at all affected by the severity of the congestive heart failure. It wasn't affected by a whole host of other medical issues. What it was affected by was, had you been in before, how long your previous hospital stay was, and then were you unemployed? And unemployed was the biggest predictor of readmissions. And so think about looking through the unstructured data, combining it with the coded data. The unstructured data for unemployed has lots of different words. So we're building in those kinds of things as well. So you can basically go after that kind of, that data would be extremely valuable in that particular case. So if I'm going after congestive heart failure patients, I would look at my population health. I would try to create a cohort that included unemployed folks, and then I would have my case managers go out and prioritize those folks. So just an example of how we think of data.
I guess following on from that, we call this clinically the so what question. It's fine to have cool technology, but people need a reason to buy it. The risk adjustment scenario that Sean's described is I think, the crispest scenario where you can actually attach you can calculate the ROI very accurately, as you've heard him describe. The other one that we've come across is identifying candidates for clinical trials, which is a significant source of revenue for provider organizations, done with highly manually labor-intensive processes, very expensive for the provider, and obviously a long lead time to market for the pharma. Those are the two examples that I'm aware of that we've seen where you can actually numerically calculate the ROI. But to Murray's point, where we see the most take-up of our technology is people trying to look for pockets of risk. I would say medication is more common than others, and some quite simple things. You'd be surprised. The conversation in the previous session in this space, somebody who was talking about data security, you wouldn't believe this, and I'm not making it up. You kind of see those sorts of scenarios in this space too, where people have to go, in our case, to unstructured data to find things that you would really have thought was available as structured. And that costs them a lot of money in terms of people and time, and that's where you get the ROI.
All right, I see a show of hands starting to come up, and we're going to start with this, and then we'll go to the
Hi, my name's Dave Schneider, consultant. My company's called 42 Tech. In the various industries I've worked in over the years, data quality has been an issue. And so when you're dealing with structured data, at one end you might have lab data where they're doing all sorts of quality control in the lab, and maybe you can believe the number. You get all the way to unstructured data, and I would begin to have questions. So maybe that the simplest way to put the question is, how do each of your approaches screen for garbage?
Yeah, it's certainly agree garbage in, garbage out. And depending on the use case, you put in place very strict guidelines as to how you screen for the data that's coming in, tracking it. So we take two ways that we track data. One is we make sure that every piece of data that leaves our client side is traceable all the way to the action. So we could look to see if that data got dropped along the way somewhere. Because as you build high-scale computing, the systems can be quite sophisticated. So one, you have to make sure that you have very strict data inventory, both guidelines and systems in place. And then secondly, you have to look at the quality of the data that you've received. So, and we have, once the data is in our system, we look to see whether it meets the application needs, and we have very specific things that we have our quality control system running to determine the quality of the data. And as you hit the nail on the head, the quality of data in healthcare tends not to be very good. You have a lot of assumptions that is often built into the data. So if the data is structured and it's well defined, doesn't mean that's good data. In fact, we call it, from a sort of more of a signals standpoint, we call that a lossy system. You have the process of coding data or structuring data, whether it's the problem list or procedures or what have you, has a lot of assumptions built into it, and therefore you've lost a lot of the color, and you try to put that color back in by looking at the entirety of the patient chart and the patient experience and test that against the context of the patient experience, which is making use of that unstructured data. So yes, it's a very challenging problem, and we found the way to do it for a very specific use case, but I think more and more as other use cases are developed in the marketplace, I think we'll find more solutions.
I would just add, one, I totally agree that I wouldn't assume because it's structured it's higher quality, and in fact, it's a little bit of a game of telephone. Who's doing the structuring? It's mostly not the doctor that's coding the information, and so there's a lot of opportunity for loss there. And then I think, to Sean's point, you lose the narrative and the context, and so you have something coded that may not actually be capturing what's happening. So I think, by and large, physician notes, for example, are very high quality. The issue is, how do you actually capture that in a way that, retains the meaning and so all the semantic approaches that we're talking about here. And then one of the other things that we do is there's a lot of coded information that's duplicated in the free text and the unstructured. So we take that and then we bang it against the structured data as a check. So we can certainly do that and then make assumptions about the fuller free text document.
Yeah, I think it's important to recognize that we're not in the precision business, okay? I mean, let's just say that out loud. Sean needs to be, okay? He's got a very, very tight use case, but people are scratching in the dark, trying to find trends and identify groups of patients and cohorts. And if you take a situation where manually they took 30 FTEs, this is a real example, 6 weeks, and those FTEs are all clinically qualified, maybe they should be doing something else like, giving care. And you look at the cost of deploying that resource to find a relatively small number of patients who had a particular set of criteria that were important for a business reason, and you reduce the pool that they have to sift through from maybe 50,000 records down to 1,000, okay, then you've delivered some value, and the fact that you've delivered some false positives doesn't matter at all, okay, because you've made such a big impact. So similarly, we have quite a rigorous methodology in terms of optimizing our technology that we go through every time we're exposed to new data. You can assess natural language processing technology using precision and recall. That's quite well described academically. So you can kind of benchmark it. Every use case is different and every data set is different. So we prefer to work with the customer or our partners to say what problem you're trying to solve, and therefore how much reliability and accuracy do you need. Totally echo what Murray said. We've seen now plenty of examples where the structured data fields have been totally absent, not populated. Why? Because They're designed to capture a core measure in an EMR that's scrambling to get meaningful use compliance. So they've thrown a load of controls on a form. No physician's going to spend the time in a consultation to populate all the fields in that form. What am I talking about? Something really obscure? No, tobacco status, right? If you want to document the tobacco status absolutely properly, the way it says you should in the book, to get your meaningful use incentive, then you need about 20 controls on the form, okay, as opposed to expressing it in narrative. So just because the structured data's fields are empty does not mean that it's a negative for that patient. And then you go to the unstructured data for the same patient, and you'll see it's actually all richly described, quite reliably described, as Murray says.
I mean, I think that's a great question. I mean, as was mentioned here, the challenges of the healthcare data is across the board. Another example I'd like to add to this is even the patient identity itself. I mean, a lot of times when you collect the patient into what we call the master patient indexing as part of a platform, you have to go through make sure that those identities are correct identities. A lot of times you have duplicate patient identities. So from the moment that you actually try to identify healthcare data related to the patient, you really need to go through an exercise of doing data scrubbing, data quality from your master patient indexing across the board. And on the provider setting to meet the meaningful use that was set, you definitely need to do that type of data quality data scrub. And we try to automate that as much as possible, but this is a space that you still have some manual intervention.
Yes, hi, my name is Becky, and I'm one of those people that does look through structured and unstructured tests to find information. Can you hear me? I'm sorry. Okay, so I have done a lot of this looking for data in structured and unstructured tests. Used databases, used looking at actual literature. And one of the reasons I'm here today is I wanted to understand the semantics of big data in healthcare. So I'm trying to understand what is data, what is information, and what is text. Is data mining the same thing as text mining? Is it different? And I really appreciate what you're doing because you're right, it's a lot of hard work for people to pull this information out. But I want to know, what is big data? It sounds like it's text and information, not numbers. And I always think of data as some kind of numbery thing. So thank you for answering my question.
I can tell you how we think about it, and I think you're right. It's not. There's no semantic definition of big data that's widely accepted. We think about it as structured, unstructured, text, numbers, anything that can be converted into information and you can take action on. And the way we think of the process then is you have to identify the data. So we think about it as entity identification. An entity can be a condition, it can be a symptom, it can be a measurement, a number. And then how do you take that from wherever it is, whatever format it is, could be text, could be anything, and then how do you aggregate it with other information? How do you normalize it? We spend a lot of time talking about normalizing, meaning that it may be the same information referred to by different names in different places. So how do you normalize that? And then in our case, we go through a process of categorization. So let's put that with other information or data that's similar. We do an enrichment process. So again, this whole taxonomy I've talked about, once we have that information, whatever else we know about it, once we know what it is, what that concept is, we can enrich it with other things that we know about it, and then we make it available for use. So it's available in an index, it's searchable, it's discoverable, it can, through APIs, be plugged into other applications. We actually have a product we call a cohort creation engine, so we're basically taking all of this data and creating cohorts that you can use directly for population health, or you can pull information out of it to build predictive modeling, or you can plug it into your decision support system for clinicians, or use it to, use it as a complex query to match up patient education or patient engagement to get people personalized information. So that's how we think about it. I'm giving you the process to put how we think about data in that context, but anything we think about as data. And if it's defined, it's discrete, and it's in a database field, then it's structured, and everything else is unstructured.
Thank you. We think of big data more as a verb as opposed to a noun. So it's not so much that there is a lot of data, is that we take a big data approach to processing the data. Just to give you an example, that's probably not a great example, but at least it sort of maybe helps you sort of better understand what our view of data processing is. We take data, and instead of reducing its information and its structure, we actually expand it. So from the data that we receive, we actually create more data, and those are the event streams. And from those event streams, we create more data, which are also larger volume of data and more variety of data. And then we start applying knowledge to it and start reducing it down to the nugget that matters to our client. So if you kind of take that narrative and think about sort of how your brain works, there's a good analogy there. For example, information that we're getting through our visual system, you only got a handful of nerves in your eyes that are receptors that are transmitting that data to your visual cortex. Well, the amount of interconnectivity actually all of a sudden blows up once it gets to your brain. And the information that's flying around in terms of its volume, it also explodes orders of magnitude. And then your brain starts applying prior knowledge and starts reducing it down to the data that matters and that one decision that obviously helps you do what you need to do. And that's actually how we use our system, the big data system that we use, is this expansion and contraction that ultimately results in that highly actionable piece of data. So we think of it as a verb, that process.
Let me share with you experience. In the case that we are dealing with, let's say population health management, patient health management, the starting point of the data is the patient identity, as I mentioned. So your starting point is that having a master patient indexing that has a valid, correct patient identity, or we call it entity identity management. And that's going to evolve because individuals throughout their lifetime of receiving healthcare are going to go through changes, names. A lot of ladies, when they get married, they change their maiden name. So that's what you need to make sure that information is captured. And all the health encounters that an individual is going to capture, and all the health data. So you can imagine how complex that becomes. In addition to, let's say, your vaccination, your immunization records, to every encounter you've had with your primary care provider, to your specialist, to your lab results, to your medical images, and now we're moving to the digital images through all these type of what's called PACS systems and DNAs that they have that. So if you really want to get a complete health and medical record of the individual and aggregate them for a population to identify your high risk, identify the chronic disease, folks with chronic disease, to manage them better as your cost eventually is going to be incurred by people who are going to get more care at the acute level rather than in the prevention level. This all aggregation collection data. So data starts with a patient, and then basically you populate that across. And a lot of times you're not even there yet. And then sometimes the gaps in that care cannot be identified purely from clinical data. Then you have to add to a claims data. Because claim data sometimes capture a different side of the story. So data becomes quickly vast around an individual, and as you build a typical IPA, Independent Physician Association, they have a population of 2-3 million physicians, the one that we're dealing with. And they were trying to collect data on the 3.5 million population they had to identify the high-risk individuals, try to identify the kind of services they care and where the cost is, and as was mentioned by Sean, where they receive the payments, because CMS provides them with different type of rating called star rating. They get 3-star, 4-star, 5-star. So to get all that information to know who needs care, where your cost is being incurred the most, and how to improve both the efficacy of the delivery process, and ultimately better quality of clinical decisions. That's where these big data that you were mentioning needs to come into action.
Yeah, I'll attempt to summarize without repeating anything that my colleagues have said. Not easy. If this was easy to understand, we wouldn't need data scientists, right? There's a whole specialism now growing up around this, which is very exciting, and they're very specialist, clever people. I liken this to cookery, basically. There's raw ingredients go in, that's the data, and that can be of any kind. Then there's an enriching process, which I think Sean described very well. And then there's a boiling off and evaporation to leave you with something that's of higher value than what you started with. To Murray's point, which gives you actionable insights, that's the buzzword. For me, I think the way I think about big in the context of big data is in 2 dimensions. As Zia said, big comes around when you start to join lots of different pieces of information about the same person or the same context, and starts to get very powerful very quickly if you can manage it. But big is also in just N, the size of the denominators. We work with a Centre of Excellence Health Informatics group in the UK, and they've been looking at very large volumes of data in healthcare for a long time. And so the reliability and the confidence that you can draw from conclusions you make on analyses of large data, even though it's imprecise, increases as N gets bigger. So I think that's for me, that part of big in big data in healthcare at least is important.
So, can you hear me okay? So I have just 5 quick urban legends that I'd like to debunk that have all been referred to this morning. And then I do have a question. Okay, this is that better like this? Okay, you almost eat the mic, as they say, performing. Urban legend number 1 is you can't rely on the semantics of HL7. As the founder of what became the CDA and CCD, I can tell you that the plan was to use encapsulation and indirection to other ontologies. So I think any assertion that HL7 is an unreliable source of semantics doesn't represent how HL7 embeds ontologies. Second urban legend is that the value of data is determined by a known business value. And I like to think of the accordion model, and someone referred to expanding and contracting. I think, Chris, you did. And we don't know the value of data yet. We're just beginning to discover the value of data, and largely the value of data, and you have to think about this in terms of the sustainability model for how you store large volumes of data over long periods of time and pay for it, is how you aggregate that data. And despite all the HIPAA concerns, the most valuable way to bring value to data is to keep it person-centric, so you can begin to understand different data types and different data sets in the context of an individual. The third urban legend is that prospectively defined, discrete, coded data is inherently more precise than free text. And I can give you numerous examples of how we disprove that over and over and over again. The fourth urban legend is that big data is about the 3 V's, but actually, the more you dig into what happens in Hadoop, which is increasingly the standard in the big data space, what you realize is what is unique about big data is a completely different way of managing semantics. In the old model, we have an ontology and a database schema, and we plug things in. And we're completely constrained by prospectively defined relationships between concepts. And those principles, design principles that are implemented in ontologies and database schemas are entirely in the eye of the beholder and their intended use cases and queries. And to the extent that you want to look at the same data for a different purpose, you are bound by those prospective constraints, and it's a bad idea. What happens in the big data world is you bring in the data and all of the atomic level metadata associated with each data point, and you can repurpose it a million different ways, cognizant of the metadata associated with that atomic level data, so you are no longer constrained by the ontologies and the canonical relationships between the unique concepts. Not to invalidate SNOMED, I have a long history of working with SNOMED and I believe in it, but it is not realistic to think that we can live in an either-or world. It's a both-and world of big data with atomic level metadata, form of semantic, and what EMC refers to, or Greenplum refers to, as model on query rather than model on load. So we're talking about not ETLs but ELTs as you begin to look at the meaning of the data. The last legend, or urban legend, is that volume can overcome imprecision. The most famous example that's used repeatedly is speed bump, where in Boston they looked for potholes and they figured they could find them all by measuring accelerometers and people driving around in cars. The problem is the poor parts of Boston, they missed all the potholes. So the assumption that you have all the data and that the volume can create some precision is itself inaccurate. There are many other examples. So those are just, some assertions about urban legends. My question is the following. Elmer Gabrielli was a very controversial and colorful figure. Are any of you aware of Elmer Gabrielli's work? Okay. So he was a very, very prominent name in the ontology world 20 years ago. And what he claimed is he had the largest ontology on the planet. And what he did is he just captured every term that was novel and he loaded it into a database and called it a legitimate discrete data term. And he was discredited on that model because there was no science behind it. It was just an aggregation. It was a lexicon, not a taxonomy or ontology. What the question I have is, the way that Google has developed Google Translation Services is they've basically used a volume approach and comparing human translated documents and just inferring relationships and translational relationships with profoundly good results. So while Elmer Gabrielli was discredited in the way that he created structured data out of unstructured data, if you think about the way Google does Google translation, is there a parallel in the world of ontologies and semantics and healthcare? And have any of you thought about approaching it that way and resurrecting the kernel of value that was abandoned in Elmer's approach?
I'll have a go first with that one, John. Thank you. The short answer.
Awesome homework.
I'm really happy with two things. Firstly, my business is still intact, given all of your urban legends. We're just about ahead. Secondly, I'm delighted to say, this is the God's honest truth, the answer to your question, to clearly think, is yes. Okay, so in very crude terms, what I would restate your question as is, look at what Google can do with brute force, right? And brute force is very much a part of how we deliver our solution, and it's becoming increasingly so. So the proportion of effort and time, actually in real time as our machine executes, that's devoted to classical natural language processing, academic, versus some of the brute force, high volume, high speed stuff, has actually changed over time since we started the company, to the point where in a few years' time, it'll be like 80-20. I defend the use of some kind of standards-based normalization in the process, and I completely concur with the idea that as the technologies get more powerful, we've settled on MongoDB. Maybe that was not a good idea. We'll see. The model at query time, which is the Valhalla, that's where we all want to get to, is going to become a reality. But I think, to be honest, for commercial offerings, then we need to use existing technologies, even if they're quite new. So that's a little bit ahead.
If I could add two quick points. So I didn't mean to imply that MongoDB and Nebula were direct. They're very complementary. So I'm not going to say anything about MongoDB. The second thing is, you mentioned your approach is evolving over time. So does language. And so the shift in drift in speciation is occurring at an exponential rate right now. And so the notion of a fixed ontology is very problematic in keeping up pace with the shift in drift.
100% agree. Yeah.
Yeah, John, we agree with you as well. Hence that I use the word or the phrase knowledge graph as opposed to ontology. Knowledge graph is a way of representing atomic level information that you could in fact gather through just collection of phrases. And in fact, these phrases, some could be meaningful, some could be not so meaningful, and you let the knowledge graph and the probabilities, whether first order, higher order, determine that. So if your system is able to make use of a knowledge graph at high scale and high speed, and that's, I think, to your second point, that you don't want information to be used in a way that's baked in. You want to be able to take a knowledge graph, apply it, and then forget it the next day after you've used it, and then reapply it again, which means two things. You have to be able to handle data at super high scale, And secondly, it has to be very economical. Because if you're going to erase everything and run it again, you have to be very economical. Hence, the big data technologies that are used by the likes of Google certainly do that.
Yeah, I was just going to add, I agree as well. I mean, we actually started to call our semantic taxonomy a semantic information graph for health technology for that very reason. But I do think, and you pointed it out, it's not an or, it's an and. And so starting with it, maintaining it, and then making sure that you can score. And at the end of the day, you're just actually comparing it empirically to what works. So although your example for Google is great, Google tried to take that approach in health, and it hasn't worked particularly well. So I think
They stopped maintaining it.
they did stop maintaining it, but the approach was raw machine learning, and there was no structure to begin with. So
There was originally human curation that they dropped.
yes, that's
They
right.
got in trouble.
And that's where we're at right now, which is the human curation is a corpus. It needs to be highly maintained, right? And then you throw the machine learning at it, and similar to what Watson's doing, it has to be a learning system. And you have to continually score it, and then you have to look, and there are measurements, as you know. I mean, you're looking at your precision, you're looking at your recall, you have to do it at scale, you have to do it at high speed. There's a couple other metrics, and so what's the right optimization approach to that? And I think it's a combination of the two.
Question in the middle?
I have a question that relates to a specific example you use and also the overall issue of credibility of these results. You mentioned capabilities specifically for the smoking status. Normally, any technology that you use for user reporting has to be certified by CMS. Were you able to get your technology certified, or how did you deal with that issue?
That wasn't our issue, right? That was a customer's issue, and absolutely the certification process is very robust, and it's entirely proper that a system that has a form with all the right controls on it to enable you to correctly record smoking status to satisfy the meaningful use criterion should be certified. Absolutely nothing wrong with that. The practical result that our customer is finding that when the EMR form contains so many controls that the user has to interact with to describe the thing, in this case smoking status, sufficiently accurately to be able to then report on it at the back end, they won't use the form, right? The user won't use the form, that's harder to regulate.
So
That's-
how did the process work? Did you take unstructured data and calculate your data structured
No.
based on
I was mentioning that situation that a customer had, okay, in relation to their EMR, and explaining that scenario as a reason for folks to start to look at unstructured data as the sources for some of these pieces of information.
Go ahead.
The increasing specificity of regulatory structures and reporting is rapidly becoming the greatest barrier to new discovery and innovation. And the higher the specificity of the regulation, the greater the impediment to innovation, and there's starting to be a backlash from Delphi finally on that very issue.
All right, we have time for one last question. You're all set?
Steve, that gentleman in the back.
Well, you guys didn't make the list, sorry. Good job with the homework, though. Good job with the homework. I had a whole bunch of stage questions, and these were way better.
The good news is from the data, the bad news also from the data. Just like ICD-10 is putting out again and again, but we are moving to the convergence direction. I'd like to know a little bit about the current overall status from the research institute and universities and the industries, the companies, what their product, what their research result. Is there any expectation how long we can use the result, the products? So, yeah, I'd like to know a little bit about the overall status of the data semantics. That.
Can you summarize the question?
My question is, what's the current status of the research all the products in the market for the big data. It's very related to the semantics.
Current state, that's probably a long answer to that question. I don't even know how to answer that question. I think there's a lot of different things that you've heard in big data, from getting the data to normalizing it to using it. There's a lot of different applications that you heard up here. I mean, I guess I'll just I'll bridge it to something that I think might be interesting. Is I think one of the biggest impacts. We talked about some very specific use cases here, but I think the notion of, right now we live in a world of, you go to your doctor and you get diagnosed and you get prescribed a standard of care, and it's based on clinical trials. That's the world we live in. That was the last major innovation in healthcare in the 1970s. And it's based on a cohort of people who went through a clinical trial. It's very controlled, and it's very unlikely that you as the patient look like that cohort. And so you're getting evidence-based treatment that's really not evidence-based for you. It's evidence-based based on the cohort of people who responded well to it. So I think if you put the technologies we're talking about together, and you have the incentives that are moving in the right direction and collaboration that's moving, you will move into a world where that'll be really old, and you'll be able to do real-world clinical trials. The idea that you come in, you get diagnosed. I know a lot of information about you. I can enrich it, like you heard everybody up here talk about. I know your socio-environmental information, your medical information, your family history. I can pull all that stuff, structured and unstructured, and I can do a search on 300 million records and find people who look like you, and then say, I gave that person this treatment or this type of care delivery or whatever it might be, and I can say, did it work? And if it worked, then I can prescribe to you in an evidence-based way that I have a very high confidence level is going to work, and I can do it in seconds rather than outdated 10-year-old clinical trial that's related to 1,000 people that don't look like you.
Awesome. All right, I think we're just at the top of the hour, so thank the audience, thank our panelists.